Hello guys, good morning. Am I audible?
Very good morning, sir. Yeah, you're audible.
Okay. Let's start. Give me a moment, please. Okay. We'll start. Okay. I'll share my screen. Let's start the further concepts in Kubernetes. Okay. Guys, we are using Google Meet from now onwards because Zoom is engaged with B11. So we'll connect with this link only. Okay, the same link going forward. Okay, no need to ask in the group that link is engaged and using some other person and all. So we are using for B11.
Okay, sir.
Okay.
I'll be sharing the screen. Entire screen. Able to see my screen. I have just shared my notepad.
Yes, sir.
So everyone worked on the assignment, right?
Yes, sir.
Yes, sir. Yes.
So application which is available for the Docker document. I used in my one of the POC project. I have created an image. Everything is available. It is ready. It is ready project. You will have to configure either of one of the pipeline from Jenkins or maybe from GitLab CI or from Azure ADO or maybe from the GitHub Actions. Okay, there is nothing that you need to configure extra, right? So you will be able to configure Jenkins, right? CI/CD. You will clone the repo and you will create a Docker image, and you can spin up a pod, which is Minikube, and you can create the services, pod creation, deployment, everything you can create from Jenkins, right? That you are getting an idea, right?
Yes, sir.
So I'm asking from everyone. Uh, is it clear, Rakshita? I'm asking you only.
Yes, sir. This clear.
Okay. So able to see my screen?
Yes, sir.
Yes, sir. Yes.
Someone wants to join. Okay. Okay. So let's start the other concepts, the remaining concepts in Kubernetes, which is labels. Labels and selectors. Labels and selectors. So both we call it as labels and selectors. Remember that we used to point selectors and match label, right? So labels and selectors in your YAML configuration when we are creating a pod, creating a deployment, creating a services. So we use labels and selectors, right? So what this defines and what are all the labels which are available in the Kubernetes. Okay. So before that, the labels and selectors that defines the core grouping primitive in Kubernetes. Means, so we are grouping it. Suppose if you want to group a particular resources, often set of application in your YAML configuration, we will give the custom name, right? So here for selector we have given app my app. So when you run, when after the deployment, when you create your services, right? When you create your services, when you print output in wide range, so you will see the selector. Okay, this is mandatory in the YAML configuration when we are creating any of the services. So before that, we should understand what the selector that we can provide. So if the selector is given, see this you can give it any name, app with according to your project requirement, according to your namespace, you can give the selector. And when giving a label, you will point my app. Means you are giving label and selectors to my app. That means how the statement looks. Okay, the label and selectors. Okay, that defines the core grouping. Core grouping primitive in Kubernetes. Okay, core grouping in the sense. So here we are grouping it, right? Selector app, the grouping app is equal to my app. So when you print your output in wide range, you will see the selector as this. So that's how we are grouping we can group in a particular namespace. Suppose if you're in a same namespace, you're grouping this app is equal to my app. You can call this selector in any of the configuration in your particular namespace, right? So when you call this app is equal to my app in the namespace called dev, this will be available in entire namespace. Means we are grouping it, we are calling it some name with the custom name base. So normally we use based on the environments or based on the application, uh, those names we will keep it under labels and selectors. Okay, so that's why core grouping in primitive in Kubernetes means this is the core grouping we call it as. Okay, so now there are two types of selectors in Kubernetes. So there are two types. Okay, the very first, equity based. Equality based, and the second one, set based. Okay, so there are two types of selectors the in the Kubernetes resources. We do use equality based and the set based. Okay, so we'll learn one by one now. So the very first, so equality based. So what this defines and what do we have in this selectors? Okay, so equality based, this represents the label, keys and the values which works on three kind of operators. Okay, so there are the operators that we use, equals to, not equals to, and right. So equality based, so I'll give a statement here, so which defines the uh, label keys. Okay, so wherever you see the kind of an operator when you are in your configuration. Okay, so that defines the label keys and the values, which works on three kind of operators. Okay, so three kind of operators. I have given the kind of an operators, right? For example, so I'll give it this way. Enter. So the operator is this way, that is equals to, again equals to, and not equals to, right? So this we call it as an operators, right? So this we call it as an operators, right? Equals to, and also we can write this way equals to, and this we call it as not equals to. So wherever we see, wherever we are defining equity based, right? Equality based that defines the labels and keys, the values, which works on three kind of operators. So which are those three kind of operators? These are all the kind of an operators which we have, which we gonna use, which we gonna make use in our YAML configuration and creating a pod deployment services. Okay. Now, so how do we use this, right? So we can use, say suppose when you are in, say like environment in production, when you're working in a production environment, right? Okay, so how do we use, right? So I'm gonna write by making use of equality based selector in the configuration. Okay, so I'll just give an example. Environment. Okay, suppose if you are working in an environment called production. Okay, so this here, instead of colon, I'm gonna use production is equal to environment is equal to production. Okay, so this here I'm using equality based selector, right? So say suppose if you are working on non-production, right? So even environment is equal to production, and tire, I'm gonna use tire not equals to front end. Okay, so tire means you are in either you are in front end or back end, right? So here also I used equality based, right? So what this two statements says, in your production, in your production environment, you should be in, you should not be in front end, right? So which means tire not equals to front end means obviously it should go to the back end only, right? So not equals to tire not equals to front end, and then in the production environment, tire should be in back end. When you point this only will understand your YAML configuration, it should select and which should define a particular selectors this way in your YAML configuration. Okay, so now how do we use this? So which works, sorry, so which works, so I'll give it to this, I'll give it this way. So we can use in a single line saying environment, I'll copy from here only, environment instead of typing. Okay, so environment is equal to prod, correct? Similarly, tire is not equals to, so is not equals to front end, right? So this way we can use the selector in our YAML configuration. This is very deeper technical part which I'm explaining here. Okay, so whenever you are using your YAML configuration, when you're configuring your any services to deploy, to expose your application, suppose if your environment is in prod, similarly it will be applicable for all the environment, like whenever you are in dev, whenever you are in pre-prod, and then production, and maybe other environments also make, they can use in the organization. Okay, suppose if you want to deploy, if you want to pass your selector in the based on the environment based labels, you can point environment is equal to prod and tire is not equals to front end, means it should be back end only, right? So this we call it as equality based. Okay, which defines the label keys and the values. What are all the values? The values are here, the key is here, this is the key, The environment is the key and the prod is the value. Similarly, tire is the key and the front end is the value. Okay, and what are those operators that we use? The operators that we're gonna use in equality based is this only. Okay, so this is an example of equality based selector. Similarly, we do have the second one, set based, right? Set based. So what this defines under set based? So it is also a this defines the label keys and the values. Okay, and this is also has the three kind of operators are supported in the set based. Okay, so I'll give it this way. So this will allow filtering keys according to a set of values. According to a set of values. Okay, so there are what tab? Okay, so there are three kind of operators are supported. Okay, so what are those three kind? Okay, so I'll give it in a brace, that is here in comma not in comma exists. Okay, so wherever you will have to use set based labels and the selector, you can use these three operators. Okay, for set based. So normally, so I used equality based. That depends on when you are configuring uh, your YAML configuration in your services when you are creating. Okay, so you can also use both, but you will have to check on which condition, which scenario that you will have to use your equality based, on which scenario you will have to use set based. Okay, so let's give an example here for uh, set based labels. Okay, so say suppose when we want to similar component, so suppose if you want to use the same scenario environment, suppose if you are working in an environment in what? Okay, so I'll keep it this way, prod comma qa. Okay, so when you define environment in, this is an environment and this is an set based selector, and these two are the environment that we're going to use in your YAML configuration. So if you point this in your YAML configuration, it will get deployed to two environments, prod and qa, right? Similarly, see suppose if I want to use tire not in, right? Not in what I can write here, front end. Okay, front end and back end. Okay, so we're not going to write both in a single tire. So tire not in front end means front end should not be get deployed. It should go to the back end only, except, right? Except front end. It should get deployed environment in prod QA and tire not in. You are able to understand this. And similarly, partition partition is not a partition. Okay, okay. Okay, so this is how the set based uh, selector will work. Okay, so when you point environment in instead of prod qa, you can also go def. Okay, so similarly, say suppose if you have labeled a namespaces based on your environment it should get deployed. See, we are tagging it, right? We are tagging it your namespace to the particular environment. So we are also defining the namespaces, and also we are also defining the labels and selectors in the YAML configuration, so that we are following the robust configuration in our what to say, in our services YAML configuration, right? So environment in prod and dev. Similarly, tire not in front end. So here we have used equality based, and here we used set based. Okay, similarly for environment in prod and dev. Okay, and so suppose if you wanted to write in a single line this statement, how it looks. Example. So I'll give, okay, partition in. So this complete statement I'm gonna write it in a single statement saying, say suppose, okay, so let's leave this example. Say suppose if you are in a multiple, suppose if you want to have multiple customer in an financial application that you are working in some of the banking sectors, right? Those to be named it as different clients, or maybe different environments, different client or different customer. So that is the case. We use partition in, let's give it as customer A. Okay. Similarly, so I'm going to give customer B, and environment, it should not be environment not equals to QA. Okay. So we can use this way by partitioning this to, instead of square brace. So I'm grouping this till, not here. Okay, and include this, and environment should not be in QA. So apart from this, so we can use, so I'm gonna remove this. This should be comma, separated by comma. See what this defines. Okay, so partition in, say like partition is your component, so you should include in both the customer, both the client. Say suppose if you are in database, like if you are using in Postgres database one side and the SQL database in other side, you can also use database A and database B. Means it should include in your partition both the database except environment not equals to QA. So we can use both set based and equality based selectors and labels in a single statement. There is no difference that we use in set based or equality based. You can use whatever the label or partition that you want, sorry, label and selector that you want. You can make use of those in your YAML configuration. So only the operator that we use in equality based is this, and in the set based we use these operators. Okay, in not in exist, right? Say suppose if you want to check the databases exist, you can point the selector database A, database B. If it is exist, partition in, include these two, not in QA. This is what it defines, right? So we can use this labels and selectors in the YAML configuration. Clear? Clear with this?
Yes, sir. Clear.
Okay.
Yes, sir, clear.
Okay. Now we do have a command. We do have a command in Kubernetes. So how do we get a pod? Right. So how do we get a pod which has label connected to these two particular labels and selectors, right? So how do we get a pod? The command.
Kubernetes.
1 minute, I'll give. What is Kubernetes?
Kubernetes get pod.
Kubernetes get pod.
Kubectl get pods.
That's why I told I'll give the command.
Okay, sir.
Don't be in a hurry. Okay. So kubectl get pods. Okay. -l environment. Okay. Equals to production or prod. You can use prod and tar is equals to front end. Okay. You can use this similar command in your production. This is very deeper technical component. When you want to debug your labels, or when you want to debug your particular the exact pod which is crashing your pipeline when you're creating, you will get these pods in out. See, this way works on when you are working in a large Kubernetes components, large amount of Kubernetes cluster. Okay, so when you are in a large production components, they use lot of like more than 50-60 clusters. Each cluster will be handling 500 TBs of memory, and think about the cluster's capacity and think about the pods capacity and the node, right? That is the case. You will be get listed with 50 to 60 pods when you run this command. So you need to debug pods, each pod, to get the pod to be listed on the environment that we used prod, and tar we used means either it should be in front end or back end. Correct. Similarly, when you want to get a pod of the environment in dev, right? So it will give a pod, right? So we'll get a pod. Similarly, kubectl get pods -o void. So it will give the environment and the tar, right? Instead of, suppose if you are not don't want to use this command, you can use print the void command, right? Output should be in a void, so it will give the complete pod output in a wide range. Okay. Similarly, how do we get a pod? This is based on the equality based. When we run this command, we'll get a pod in a equality based, right? Similarly, how do we get a pod when we use the set based selectors or labels, right? So we do also have kubectl, because I'll be using this command to debug the pod which is tagged to the particular environments, particular either it should be in a front end or back end. Okay. So similarly, the pods list to be used in a set based selectors and labels. Okay. Kubectl get pods -l. Okay. So similar command environment in, instead of equals environment in, I'm gonna use as prod. Okay, so I'll remove this prod comma tar in front end. Okay, so this is the command. Okay, so I'll give equality based, and this is set based, correct? Okay, so to get a pod which we used in equality based selectors and labels, we can use this. And similarly, when we use set based labels and selectors, we can use this. Okay, so there is no mandatory like we should only use equality based or we should only use the set based. You can use a mixed way like this. Okay, so either of way you can use the labels and selectors in your YAML configuration. Clear with this? Any questions and any doubts, guys?
No questions, sir. Clear.
Clear with everyone? Rakshita.
Sir, ಅದು equal and double equal is same, sir.
Yes.
Select equality in the inequality, sir.
Hmm.
Equal and equal are same.
Yes, these are all same only. So you can use single equal or double equal. That depends on the operator. Suppose if you wanted to use, say, remember that in the scripting component, when you want to use compare your numeric, right? So
Yes.
suppose all our environments are in Bash Linux environment, right? Suppose if you want
Yes.
to use the numeric comparison, right? So env is equals to 3, means you need to define 3 environments in a single statement. That is the case when you are comparing your numeric, you can use this, right?
Yes, sir.
That you should make sure that when you are using single equal and double equal, and this we can understand that not equals to, it should match the particular component. When we are working in Linux, we should use that when to use single equal and when to use double equal. Because I used one of the namespace to create double equals when I'm comparing with a numeric operator. Clear?
Yes, sir. Yes, sir.
Yes. But both are same. Equals. That's what your question, right?
Yes, sir.
Yes. But we should think on when to use single equal and when to use double equal, but both the meaning are same.
Okay, sir.
Okay. Fine. Now, if not having questions, I'll move to the next concept. Clear, right?
Sir, in equality based, we will use only these operators. No other operators we will use.
No. Only those.
Only three operators, right?
Yes, that's what I said, right?
Yes.
Only
Yeah,
3
yes.
operators.
Yeah, you said, but what about the greater? No operators will use.
Did I told the greater or less than here?
No, you didn't
That's
say.
what I told, right? So clearly I have said here, which works on 3 kind of operators, correct?
Yes.
You can see the 3 operators here.
Yeah, equal to not.
Similarly, 3 kind of operators are supported in set based. You can see the operators here in, not in, and exist, correct?
Yes.
Ah, this is what your question.
Yes.
Are you clear on your doubt?
Yes, clear.
Okay, I'll move to the next concept in Kubernetes, which is auto scaling. Okay, so it is very important component in Kubernetes we use. Okay, so basically auto scaling we can achieve through the deployment, right? So when you create a pod also, it will recreate the pod automatically when we have deploy the deployment, correct? So auto scaling is basically, the auto scaling defines the capable of increase the number of nodes as on demand increases. Similarly, decreases the number of nodes as on demand decreases. Okay, so whenever there is a load on our cluster, node creates that based on the content of request, based on the load, it helps to create a multiple resources, multiple pods and multiple nodes in our cluster. Similarly, if the load decreases on demand, it decreases the resources to be created. So called auto scaling in Kubernetes. Okay, so I'll give the statement this way. This defines the uh, this defines okay, the cluster is the cluster is capable of increase the number of nodes as on demand increases. Okay, and decrease the number of nodes as on demand decreases. Okay, so on demand decreases. It's not gonna happening. Okay, so basically, the cluster is capable of increase the number of nodes as on demand increases and decrease the number of nodes as on demand decreases, right? So called auto scaling. So whenever there is a load is more, node will helps to create the more resources in the Kubernetes cluster. Okay, and similarly, if the load is less, okay, and based on the on demand, it decreases by creating a resources, so called auto scaling. It should balance the scaling of our resources, scaling of our on demand pods creation, on demand deployment, on demand services. So that works on the auto scaling. Okay, similarly we do have Kubernetes auto scaling mechanism works on two layers. Okay, I mean uses the two layers. Okay, so Kubernetes auto scaling mechanism uses two layer. Okay, so what are those two layers? The very first we call it as pod based scaling. Pod based scaling. See guys, this is very important. And the second one, node based scaling. I mean complete auto scaling is important. Okay, I'll give it as a capital. Node based scaling. Okay, so out of these two, pod based scaling has two types. Okay, so I'll give it as A, horizontal pod auto scaling, which means HPA. We call it as HPA, means horizontal pod auto scaling. Similarly, the B I'm gonna call it as vertical. Okay, vertical pod auto scaling. Okay, which means VPA. Okay, so you need to remember HPA wherever we call HPA, which is horizontal pod auto scaling, wherever we call VPA, which is vertical pod auto scaling. Okay, so normally we use horizontal pod auto scaling, which scales based on the load on demand, increases the resources, based on demand decreases if there are no load. When we configure auto scaling, we can avoid the resources used in a idle time. Correct. So if your creator resources of around 200, if you are when the load is very less, you will get costing more, right? Correct, right? So based on the need based, we can create a resources, right? So that uses the auto scaling, helps to scale up when on demand, when the load is more, and scales down automatically when the load is less. Simple. So called horizontal and vertical pod auto scaling. Okay, pod based auto scaling and the node based auto scaling. Out of these two, pod based has two types: horizontal pod auto scaling and vertical pod auto scaling, which is HPA and VPA. Okay, now so what is mean? So out of these two, we preferably we use horizontal pod auto scaling, which is HPA. You can keep remember whenever we are talking about the auto scaling, we prefer only the horizontal pod auto scaling. But before that, you should understand there are two types out of pod pod based scaling and node based scaling, and out of pod based there is horizontal and vertical. Okay, so we do prefer only HPA, means horizontal pod auto scaling. So this horizontal pod auto scaling HPA will achieve the auto scaling on demand requirement starting the horizontal pod auto scaler. Means there is a component from Kubernetes which is auto scaler that helps to create the horizontal pod auto scaling, and we can also use the command to create HPA horizontally. Means the name we call it as horizontal. Okay, you can explore more in horizontal and vertical auto scaling to scales the number of pods based on the content of request or based on the load in the Kubernetes component. So I'll give a statement, the simple statement. So normally we'll not use the vertical pod auto scaling. We use the only HPA. We call it as HPA. Remember that where wherever we use HPA, it is horizontal pod auto scaling. The interviewer may ask what is HPA. You can say horizontal pod auto scaling. Whenever the load increases, creates the pod. Whenever the load decreases, it based on the on demand decreases the resources and increases the resources. Okay, so horizontal pod auto scaling will achieve the auto scaling. Okay, auto scaling on demand requirement. Okay, starting the horizontal pod auto scaler. Okay, so there is a component called autoscaler which helps to create the pods automatically. Okay, so how do we get created? How do we do the HPA? Which is, say suppose if you are in an Apache Tomcat server that you deployed, that you created as a Docker image, and that you deployed through the Kubernetes cluster as a web application, right? So here is the command kubectl autoscale deployment. Okay, so I'll give the PHP Apache. PHP Apache is an application, the front end, sorry, for web application. Okay, this way. And suppose if you want to increase the CPU of your memory, hyphen CPU percentage to 50, either it may be in MBs or KBs or maybe in TBs or GBs. Okay, and hyphen min to 1 and hyphen max to 10. Okay, so this creates the auto scale deployment of the Apache Tomcat server, or the deployment, the images of the CPU percentage of 50, increase it to the 50 if it is less than 50, minimum pod 1 and maximum to 100, sorry, maximum to 10. This creates your auto scaling based on the needy. You're getting my point. See, in between 1 to 10, it creates, suppose if the load is less, it creates 1 or 2 or maybe 5. If the load is more, it creates till 10. Right? Think about the Apache that we have maximum of pod auto scale deployment of 10. It can survive 10 application at a time. 10 application in the sense, suppose if your domain www.jenkins.com, that is one application, right? Similarly, you will have www.yourmaven.com, www.python.com, www.yourruby.com. Similarly, we can handle 10 application in different pods on demands. Suppose if you are running your Python, only the Python application, it will create only one by running this command. We are setting the deployment to auto scale, which is HPA. Getting my point here? Which is horizontal pod auto scaling. When we run this command, this is based on the debug component, debug command that we gonna use. Suppose if you debug your pod saying your CPU is very less, means your memory, and you will be increasing it to 50. Okay, suppose if you want to make it MB, it will create 50 MB. Suppose if you want to create it in GB, it will create 50 GB. Normally will not go for 50 GB. We'll use only in terms of MBs or KBs. Okay, Now minimum to 1 and maximum to 10. It creates the 10 pods maximum and 1 pod minimum when we configure auto scale in our deployment. That's why we use this command. This is temporary fix, hot fix, right? Correct, right? Based on your, when you are in a production, you will use this command to debug this. Getting my point? So this is how we do the auto scaling, which is horizontal pod auto scaling. Okay. Now, so I do have the HPA diagrammatic representation. It creates based on the based on your load. Okay. So how this HPA works? Suppose, so I'll give it a diagrammatic representation. So how do I give? I'll take this. Okay. Say like you will have your HPA configured. I'll take this. Okay. So you will have this HPA. Say like it is an HPA, which is horizontal pod auto scaling. I will call it as HPA. Okay. So this creates, based on this, we do create a deployment, correct? Remember that we do create a pods by creating a deployment, right? So this we call it as deployment. Deployment. I'll write it this way, deployment. You guys are with me, right?
Yes, sir.
Yes.
Yes, sir.
Deployment. This we call it as deployment. So here we created, say like 5 pods. Okay. So how do we configure it as an auto scale? When you run this command, kubectl auto scale deployment means it looks for the deployment configuration. Say suppose the replicas when you point 3. Remember in our YAML configuration we want to point replicas, correct? Where is our deployment configuration? Deployment, this is service. Replicas here. Instead of 2, when you create 10 here, say like it creates the 10, but we don't want to use complete 10 pods in out of the configuration. Okay. So it uses based on the needy, correct? So it creates the based on the needy and it will make use of those resources created pods by creating a deployment, right? Now, we don't want to create and keep it in 10 pods as a replicas in the Kubernetes environment. We don't want to create it, but we are tagging it a particular selector and a label. By creating those, it picks the particular pod to the particular component based on the on-demand content of request that we can achieve through this HPA, which is horizontal pod auto scaling. You're getting it now? So when we configure this horizontal pod auto scaling, which is HPA, we can achieve based on the on demand out of 10 pods, it will be having only one, right? Suppose if you are handling only one application, it should be created as one. Suppose we can also have the same capacity, same the application when we want to have the 10 application at a time, we will be having deployments of 10. Means the auto scaling that we are keeping it, we are limiting it to 10. So the cluster can withstand up to 10 deployments, 10 applications at a single time by configuring this auto scaling. It scales automatically. Okay. So after this deployment looks for the pod creation, correct? Similarly, pod 1 and pod 2 up to pod n. Okay. So this I'm going to give it as pod 1 and pod 2, and this is pod what? N. N means based on the based on the needy nth pod, correct? So suppose if you create deployment under replicas when you point 10, this will be the 10th pod, means the pod n. Okay, for your understanding, I'll be giving it as pod n. So this is how this auto scaling works in a particular Kubernetes environment. Clear? Now, here we use a terminology called metrics server in the, so I'll share this in the group. Okay, no worries. So here in the HPA, which is horizontal pod auto scaling, we use the terminology called metrics server. So what is this metrics server and what this defines and what do we collect from this metrics server? So metrics server is basically, it serves or fetch the resources metrics from the kubelets and exposes them in the Kubernetes API server. Remember our Kubernetes architecture, it collects the resources of our Kubernetes complete environment from the kubelet through the API server. It only works on the metric server. Okay, it collects the resources through the Kubernetes API server, so called kubelet or kube API server, correct? So called the metric server. So I'll give it this way. So metrics server. So this is the component. Metric server fetches the resources from the kubelet. Okay. Resources from the kubelet and exposes them in the Kubernetes API. Someone is pinging from the Kubernetes API, from the Kubernetes API server through the metrics API for use by HPA and VPA. Through the metrics API for use by HPA and VPA. So whatever the resource that we used by HPA and VPA will collect through the kubelet and expose us through the Kubernetes kube API server, so called the metric server. The interlinked between the kubelet and the kube API server, which we used for HPA and VPA, will collected by metrics server. Metrics in the sense your application logs, where the CPU utilization and your memory, your complete. When you deploy your code, it should monitor your CPU, right? So which is monitored by metrics server. That's it. There is nothing here, nothing complicated here. Just I'm giving a statement for metrics server. Okay. So now, how do we debug your metric server? How do we get to know this, your CPU utilization and your resources to be consumed from through your Kubernetes component? Okay, so to get to know that, we use kubectl top nodes, because the loads are handled by nodes only, na? Correct? So nodes will be having pod will be having our Docker image, means the actual pod will happen inside the node only, right? So when you point your particular kubectl top nodes, you will have the load capacity on the node. Getting my point here? Similarly, kubectl top pods, this is for a particular, you can also point the pod name. Similarly, pod name. Similarly, here the node name, kubectl top nodes node, you can point the node name. Okay, load on the particular pod. Load capacity on the pod. So this is how this will collect by the load and the metrics will be collected by metric server. So which is handled by particular node and the particular pod through the kubelet, which is connected to the kube API server, right? Which exposes the Kubernetes API, correct? Exposes in the sense which monitors our resources, which is handled by, say suppose when we use HPA, horizontal pod auto scaling, when it increases the pod creation, it will be consumed by your CPU, right? So it will be monitored by your metric server. That's it. That, guys, this is very deeper technical way that you are. This will help you to debug your node, debug your pod when you configure HPA in your Kubernetes environment. Clear with this? And you will have to use kubectl top node to debug your node and top pod to debug your pod. Okay, so this is how your metrics collected by your kube API server and which monitors by metrics server. Say suppose if you have CPUs reached more than your capacity, you can increase it, right? This way. This is a temporary fix. Based on when you are in a production, you can fix it temporarily. If you want to fix it permanently, you will have to configure in your deployment, or we do also have the Helm charts in Kubernetes. We do configure all the services, all the pod deployment services, and ingress and egress we can completely define in Helm charts in the complete package. So I'll explain in further session. So how do we use, where do we fix all the resources in Kubernetes component, Kubernetes services in a single concept called Helm charts, Helm, HELM. I'll explain that. So before that, we should learn all these things and we should know what is this HPA and VPA and how do we configure and how it works and how it gonna make use in our Kubernetes environment. Clear with this? Auto scaling and labels and selectors. Any questions and any doubts here? Any questions, guys? Okay, so if not, I'll move to the next concept, which is RBAC, role-based access control in Kubernetes. This is very important in the Kubernetes. You guys are with me, right?
Yes, sir.
Yeah.
Rakshita, you want to ask something?
No, just I replied for your question. That is.
Okay, fine then. So the very next concept, which is RBAC, that is role-based access control. So why do we use this? Why do we implement? Why we wanted to use this RBAC in our Kubernetes component? Okay, so the role-based access control defines the security for the cluster. See, we should have the robust security for our Kubernetes cluster, right? And restricts the resources within the cluster. Correct, right? So we should restrict the resources within the cluster. That purpose we use RBAC, which is role-based access control. Okay, so I'll give a statement here. Role-based access control. Okay, so which helps to secure for the cluster. Okay, and restrict the resources you can make spelling mistakes also, you can make correct from your end. Okay, so and restricts the resources within the cluster. So within the cluster. Okay, so which means, so RBAC is the component, the concept that we use in our Kubernetes projects, which is RBAC, which helps to secure our cluster and restrict the resources within the cluster. Okay, so there are 4 layers which works on. There are 4 layers which works on 4 layers. I'll give this statement this way. This makes sense. Which works on 4 layers. That is the very first cluster role. Okay, so entire cluster will be secured. Entire cluster will be secured. Okay, and similarly, cluster role binding. Role binding. So this defines binding a cluster role to a specific account. Binding a cluster role to a specific account. Okay, specific account in the sense, suppose if your account subscription will be having your based on your environment, you will have the cluster role binding, which is RBAC. The third one, role for a specific namespace. Okay, for a specific namespace. Okay, and similarly the fourth one, role binding. Okay, so this defines binding a role to specific account. Binding a role to a specific account. Okay, so here cluster role and cluster role binding, role and the role binding. There are 4 ways that works. RBAC works on 4 layers, which is cluster role. Cluster role is basically the entire cluster, your service, your pod, deployment, everything, including namespace. Suppose if you want to restrict your particular namespace, you will have to use cluster role binding. There are difference in cluster role and cluster role binding. Binding to a cluster role to a specific account. Specific account in the sense, you'll be having multiple accounts in the sense based on the environments or based on the code, either front end or back end. Okay, so similarly for role for specific namespace. So we'll be when we have a multiple namespaces, we wanted to restrict a particular namespace to, we should not disturb this that namespace by configuring this RBAC, which is role, and the role binding a role to a specific account which is tagged to the specific namespace, which is tagged to a specific namespace. Okay, so called RBAC, role based access control. So this is how we do secure our cluster and our resources. Clear? Any questions and any doubts, guys? So you can explore on what command that we use to configure RBAC and cluster role for cluster role binding, role and role binding. You can explore on it. So there is a simple command will be available. You can explore on, and also the debug part. Okay. So any questions and any doubts, guys? RBAC and auto scaling and labels and selectors on these three component. So I'm going to share this in the group, and also the diagrammatic representation of the HPA, which is horizontal pod auto scaling. Any questions, guys?
So Sandeep, in the auto scaling, you said it is temporary fix, right? Scaling up
Command, yeah. So
Yeah.
this is the command, which is the temporary, where the command it went here. So this is the temporary fix. I mean, basically the hot fix. Yes.
So when you say it's temporary fix, the CPU percentage, will it go down again, or why
Yeah.
do we say this is a temporary fix?
See, so this, say suppose when you redeploy your deployment, again it will go to the configuration that you configured with the CPU percentage in your deployment, right? Again it will
Whatever the resource that we give in the deployment YAML. Okay.
exactly. So for the temporary fix, we are increasing it to the 50 MB. Suppose in your deployment will be having some 20 MB based on the resource that we divide. We're increasing it to the 50 MB and we're increasing the maximum pod to 10. And when you redeploy your deployment, the default value, it will pick the default value. Correct, right? So based on that's what I said, this is the temporary fix. So we wanted to achieve this permanently. Either we should do it in our deployment configuration. That's it.
Okay.
Yeah. Any other questions again? Guys, this is very important and this is too much of technical component and you should explore more on this HPN, VPA, RBAC and labels and selectors. Anyways, we have used it, but auto scaling will explore more in Helm component when I'm explaining the Helm charts. Okay. So before that, we should know some of the component from these areas. And also I'm going to start ingress from tomorrow. There are a lot of syllabus in Kubernetes. Okay. But you should match, you should work daily, understand this. And if you have any questions, you can ask me. Any doubts and any questions, guys? Okay, if no questions, we'll disconnect, and again we'll connect tomorrow same time. And guys, classes will be regularly from today that we started, and no need to ask in the group that regarding the class. And evening will be definitely QA. But I got the feedback from Sandeep that you are not prepared yet. What is the blocker here, and what is the point? Just you can say the concerns here, because see, he said completely only 4 to 5 candidates are prepared. So based on that, it will affect on my explanation, the first point. Second point, your understanding level. Am I going faster, or am I not clearing your doubts and your understanding level? What is it? I need to understand from you guys. Because ultimately, end of the day, you need to work on the same concept, right? So we can wind up the session by 1 or 2 days. No, we should not do that, right? We should give a time to prepare and we should explain more and we can dig more, right? By assigning, by engaging QA, by engaging sessions, by engaging any of the unknown concepts, correct? What is the problem here, guys? Because I need to understand. Let me correct from our end. What is the problem? You guys disconnected or are you in the still session?
Those are on call.
Let me check. Yeah. Okay. Now I'll stop sharing my screen. Okay. Now tell me what is the problem here. We have a count of 15. We have removed some of the candidates after the second mock, right? Now it reduced to the count of 15. Out of 15, only he said 4 to 5 candidates are only. Rest all are dummies still. I have the list. Veeresh, Siddesh, Rakshita, you guys are unfit for this, to be frank. When you will be prepared? See, our sessions are not like only one way. Our sessions are interactive way. Correct? Correct, right? Are we not clearing your doubts? I just wanted to understand from you guys.
Yes, the pure clearing.
Then what is the problem here? See, this is the only thing that you need to work on, no? Right? So through this only you will get a job, you will get more package. You guys, why you guys are not understanding this? See, we are not in school and colleges here, to be frank. We are in a professional that we wanted to get a job and that we need to learn these things, right? Then why you guys are not learning these? It is mandatory. You should learn this. This is how you need to go. This is how you guys have to learn. This is how you need to speak. Correct? What is the problem here? Because if you're not learning these, even though when we cover the syllabus from our end, it is waste. So we'll do cover all the concept, that no worries on that. But if you're not learning, if you're skipping to learn the day, skipping to learn those concepts on a day, again some more concepts will get added and you will get confused with all the concept. Okay. Amruta B,
Yes, Sandeep.
clear on all the concept?
Yes.
Jairam, Niharika, Sharif, Pooja, any questions and any doubts, guys? See, we are planning to place off count 14 to 15, but you guys are still in the lack of knowledge. You are not prepared as per the industry standard, as per the interview standards. Okay, so you will get to know when we start our interviews. Okay, but before that, you should be learned and you should be prepared. See, they'll ask like anything. They'll ask, what is computer? Sim- to be sure that they'll ask like how this command works and what is the base level, that we should understand clearly, right? They will insert like anything. Okay, anyways, we'll connect tomorrow, same time. Let's focus more on Kubernetes remaining component. Sharif, you want to say something?
And also, sure, like we'll work on it, sir, regarding this interview.
Yeah, that's what. So we'll be having QA evening.
Okay.
Join on time, learn the concept. See, you can ask doubts, guys, right? You can work on this, but doubts, I told already, the doubts I can understand how you are asking and what you're speaking. But the doubts are when you worked also, when you dig more also, you were not able to understand that. You did not get the proper direction to move forward. So called doubt, as per my understanding. I can understand when you're asking a question. The doubts are like doubts should be the Rakshita's doubt. That is not the doubt. Getting my point?
Yes.
Okay. Let's connect tomorrow, same time. Thank you. Bye bye.